Okay. Welcome, everybody, to this very special session of OA Week. My name is Katarina Shaw. I'm with the GOA-ON Secretariat, and it's an absolute pleasure to help host this session. I would just like to point out that this session is being recorded, and GOA-ON is proud to present this session. OA Week, as you might have known, is sponsored by 4 organizations. First of all, GOA-ON, the Global Ocean Acidification Observing Network. Second, NOAA, the United States National Oceanic and Atmospheric Administration. Third, the IAEA OAICC, which stands for the International Atomic Energy Agency Ocean Acidification International Coordination Center. And last but not least, the IOC, the Intergovernmental Oceanographic Commission of the United Nations Educational, Scientific, and Cultural Organization, UNESCO. As most of you are aware, GOA-ON was established in 2012 with just a handful of members. Since then, it's grown tremendously. We now have over 1,200 members from across 110 countries. GOA-ON also consists of 11 regional hubs, which span across continents and oceanographic regions. We've already heard from most of them during OA Week, but there's a few more coming. If you're not a member of GOA-ON yet, we encourage you to join up today by visiting our website, goa-on.org. OA Week debuted in 2020 and returned in 2021 when events and conferences were postponed due to COVID-19. Following the successful in-person symposium on the ocean in a high CO2 world in 2022 in Lima, Peru, OA Week has become an annual event to maintain the momentum around OA research and to provide a virtual platform for the ocean acidification community to exchange their latest findings. We are thrilled to present a wide range of ocean acidification topics and speakers from around the world. I have a few words on housekeeping before we properly get started. During the presentation, all participants are in listen-only mode. You're welcome to type any questions and comments into the Q&A box, and we'll also, at the end of the session, have some time for you to raise your hand and we can call on you and you can say hello to Dick in person. So with this, I would like to hand over to our moderator for this session, Dr. Jan Newton, the GOA-ON co-chair. Jan, the floor is yours.
Thank you so much, Katarina, and thank you to everyone who's tuning in today. It's my honor and my pleasure to be here to moderate this session. I think we've got a great time to share together. I've got some slides that I'm going to share just now, and we'll get into the program. There we go. So today we're going to, first of all, it's, just this morning, as my husband and I were sipping coffee over the Seattle Times, the WMO said in its latest bulletin on greenhouse gases that CO2 growth rates have now tripled since the 1960s and reached levels that existed more than 800,000 years ago. I find it amazing that we are, that was released in at least our local news on the day that we're honoring Dick Feely for all of his contributions to making the world more aware of ocean acidification, what's going on, working to highlight impacts, that sort of thing. And so today's program is really to celebrate Dick, but also for those of you who are maybe earlier in your career to really look back on history and see the power of a person and people working together in making the change that we've seen for GOA-ON, and thinking about how you can fuel that with your work and your dedication. So we're going to have a couple of short talks, one by Chris and one by me, on Dick's role in OA history and GOA-ON history. And then, as I said, around the world, reflections around the world. And here you see the people that we're going to hear from and where they're speaking from today. Then we do get to hear from Dick, and I'm so excited for that. Unfortunately, Simone Allen, who works with Dick, and also Adrian Sutton are on furlough, and we're really missing those two individuals today. I'm going to briefly introduce Dick, and then we're going to hear his perspectives. As Katarina said, there will be some time for you to chime in at the end, and we'll talk about how you can contribute even more. Okay, so over to our first speaker, Dr. Chris Sabine. He's at the University of Hawaii in Manoa. And I first met Chris and Dick together. They were a dynamic duo, and the floor is yours, Chris, to talk to us all about the contributions that Dick made with OA research. Over to you.
Well, thank you. It's a true honor to contribute to this tribute to Dick Feely and the contributions that he's made to ocean acidification. I've known Dick a long time, and we've been very close. I like to joke that both of us have been doing ocean acidification research since long before that was a thing. And as ocean chemists, we're focused on understanding carbon cycling in the ocean and the drivers of carbon cycling. And in particular, both of us had a real focus from the beginning on marine calcifiers and the role that they play. In my case, it was benthic calcifiers, particularly with my graduate work here at the University of Hawaii way back when. In Dick's case, he was focused more on the pelagic calcifiers like pteropods. Anyway, Dick invited me to join PMEL and work with him back in 1999. And I just had to tell the story that when he hired me in 1999, he said, Chris, I'm hiring you because I plan to retire in about 5 years. And, I want you to kind of prepare to take over the lab. Yeah. So fast forward 5 years, Dick Feely is still going strong. And it was 2004. And that's when I really feel like the ocean acidification movement began. And I want to just add a caveat here that, whenever there's a large international movement like ocean acidification, there's always different perspectives on, what really were the key moments that got it started and how it came to be. So, what I'll present is certainly my perspective and our perspective from the ocean chemistry side, because in the 1990s, we were really focused on answering the question of where is the missing CO2 sink, right? So at the time, Charles David Keeling was doing the atmospheric CO2 measurements that had grown into a global network of atmospheric CO2. We had a good understanding of how much carbon was accumulating in the atmosphere. We also had an idea of how much CO2 is being produced from burning fossil fuels and land use change. And we recognized that we were producing about twice as much as what was accumulating in the atmosphere. So the big question at the time was, where's the other half going? It was thought that the ocean modelers were suggesting that perhaps that was going into the oceans, but we didn't really have the measurements to be able to prove that definitively. So that's what we were really working on in the 1990s, particularly with the WOS and JGOF's global CO2 survey. And that's what Dick and I were working on when he brought me over to PMEL. So finally, in 2004 was when we were prepared to publish our first real article that quantified the amount of anthropogenic CO2 that was in the atmosphere. And Dick graciously agreed to let me take the lead on that paper. But not to be outdone, Dick decided to write a companion paper that went with it that really focused on the impact of all that anthropogenic CO2 on marine calcifiers and calcification in the ocean. And we decided that this was kind of a big deal and wanted to submit that to science. And we submitted the two papers together, recognizing that something like 0.1% of all companion papers that get submitted to Science actually come out together. But we decided to go for that anyway and managed to convince Science that both of these papers needed to be published back to back in the same journal of Science. And in fact, Dick was able to, they agreed to give us the cover, and Dick was able to get a lovely picture of a pteropod to put on the cover of that Science issue to highlight that work. Anyway, where I think this really kicked off, in my view, was at the first Oceans in a High CO2 World meeting. So that meeting in Paris in 2004 was really focused on trying to understand the ocean's role in the global carbon cycle and how the oceans were absorbing anthropogenic CO2. And at least my perspective, and I think the perspective of a few people, thinking about, all right, if the oceans are absorbing a lot of CO2, how might we perhaps enhance that, and how would we understand that? There also, at that time, was a lot of work being done on proving the Martin hypothesis and looking at ocean fertilization, right? And how does that affect ocean carbon uptake? So the first high CO2 meeting was focused really on how much of the ocean's absorbing, and kind of really, even though it wasn't a term back then either, really was this marine CDR at that time, again, kind of focused on the biological aspects of how the oceans might absorb additional CO2. So we all came together in Paris, and so I was presenting our first estimates of anthropogenic CO2. Dick was talking about the impact on marine calcifiers. And then the biologists were there too, talking about their studies at looking at the impact of CO2 on marine organisms, particularly, Ulf Riebesell was talking about the coccoliths and the impact of the CO2 on coccolithophores. We had Joni Klippas and others talking about the impacts on coral reefs. And so there was this first time, really, I think, when the biological oceanography community was really getting together with the chemical oceanography community. And kind of in the middle of that meeting, we really had this, I think, kind of an aha moment of, hey, our thing really relates to your thing, and your thing really relates to our thing. And we should really get together and talk about that. And that really was kind of, in my view, the beginning of this whole thing. I have to say, if there's kind of one regret from all of that we took away, is that it was a really exciting meeting, and Dick and I were really jazzed to continue to do this research when we came back home. But we unfortunately were not the ones that came up with the catchy term. So at the time, Dick and I were really thinking of this as the other CO2 problem. And it just didn't really catch on. And it wasn't, there was a Royal Society meeting that happened shortly after the high CO2 meeting, where they really coined that term, ocean acidification. And I remember sitting in Dick's office going, dang, why didn't we think of that term? That's a great little catchy term that we'll never get credit for. But anyway, the rest is history from there. And I think I'm just about out of time. So let me pass it back to Jan and say it's been a real honor working with Dick over these last 26 years. And I'm glad to see that that 5-year time horizon for retirement has finally gotten a little bit shorter.
A lot shorter.
Yeah, I wasn't going to mention how many years I've heard that you were going to be retiring, Dick, but I'm glad you brought that up, Chris. Thank you so much, Chris. That history is just so rich. I learned some things that I didn't know. So I really appreciate that you shared that with us. And I'm really happy that this is recorded because we can use this to share with students and such. All right. So I have some slides because that's how I am. And definitely a visual person. And so this is a really brief history of GOA-ON and how Dr. Richard Feely, or Dick, as we love to call him, has touched it. And I offer this on behalf of Steve Whitcomb, my co-chair, and I, and really glad to be able to share this. I absolutely love this picture of Dick because there he is with his GOA-ON, name badge. This is the meeting we had in Hangzhou, China. And one of the things we know about Dick is that you're always asking really good questions, insightful questions, questions that get people thinking. And so I was so happy and plus you're wearing GOA-ON blue on your shirt. So that was really well done. Thanks, Dick. All right. So yeah, as I thought about how to craft this talk, and thinking about how does it happen, right? So how do things form? So you have these disparate things, right, represented by these shapes. How do you get from there to something, which in this case we're going to say GOA-ON, right? And so it's a lot of coming together of different things, and this could be different locations, different expertise, different opportunities, but it comes together, and it doesn't just come together by chance. There's that catalyst, that effort, that magic, that star that really helps to bring this together. That's human effort that really does that. But then once you've created something, it doesn't just exist, it goes forward. And again, you need that extra bit that's going to help and keep guided. And so this is where I want to explore a little bit more and think about the history of GOA-ON. So I think one of the milestones for GOA-ON started before GOA-ON did, of course. That's how things work, right? In 2009, there was the edition of Ocean OBS 09 in Venice, Italy. And during that meeting, there were a lot of talks that had to do with the carbon cycle and biology. But there was a paper of a community vision for an ocean acidification observational network that would be international. So that is basically GOA-ON without saying its name. And look who was the senior author for that. And we have folks in this Zoom room and beyond who were also co-authors on this paper. So the vision was really that these people coming together saying, we really need this. And so that was in 2009. One of the other milestones that I think about is a bit more of a personal one. And so I need to tell you a little bit of my stories. But in turning the vision into something, the ingredients involved Libby Jewett, Dick, some end-of-year funds they had, and a phone call. But before I explain that, let me tell you what I was doing around this time. I was a oceanographer studying Puget Sound, and particularly the dissolved oxygen in Puget Sound, which was causing fish kills. We had a Hood Canal dissolved oxygen program focused on, really just like a Jacob study, trying to understand all of the processes and how were humans and or climate affecting this. And it turns out it was both. But one day I ran into Dick Feely and he said, I really want to talk with you because you're studying oxygen hypoxia and I'm studying carbon, the other end of the equation. We need to connect more. Well, we did. And it was my honor to invite Dick and Simone on a Puget Sound cruise, continuing a University of Washington time series and bringing UW and PMEL together on a cruise, that this relationship has perpetuated over time. I won't go into that. But these data that showed the critically corrosive waters in Hood Canal, where I was studying hypoxia, guide us to this day and really made my connection and collaboration with Dick a real one. And so in 2011, the phone rang, and with the question behind it, would you host a workshop at the University of Washington? And I knew exactly what to do. Answer the phone, say yes. And so in saying yes, we were able to host a workshop at the University of Washington. 62 people from 22 countries who came to Seattle in June of 2012. The name GOA-ON was born. And also we discussed many of the requirements, the specifics, but also things like data quality objectives. We had people like Dick and Andrew Dixon and others, chemical oceanographers, saying like, well, we need this kind of data quality, and other biologists or coastal oceanographers saying like, yeah, I don't really think we need that level. And we realized we were asking different questions, and that's where the concept climate versus weather data quality objectives originated. And there was a big sigh in the room of just, yes, this is one of the defining things that we still talk about today in GOA-ON. I don't want to say that Dick was a lone person in working on GOA-ON. I don't want to undermine this. This is a graphic from Libby Jewett, the OAP director at NOAA at the time. And these are all of the forces, the international drivers that contributed to the development of a global ocean observing network for ocean acidification. And so you see a lot of efforts, disparate efforts, and many of you were involved in these. And I think it's really important to reflect on how many things came together. But I will say that Dick is one of those. And here is a copy of the Seattle workshop agenda, day one. And you can see the second talk was delivered by none other than Richard Feely. And what are the possible components of an ocean acidification network based on existing resources? And I know Dick worked a lot with this international audience, many of whom you'll hear from soon, to put that together in 2012. Then in 2013, 1 year later, Phil Williamson brought us to St. Andrews, Scotland, 87 people from 26 countries. And that's where the GOA-ON Executive Council was formed. We created what we affectionately call the Blue Book, the Requirements and Governance Plan, that's available from our website. And the first GOA-ON Executive Council was self-formed. We just said, okay, this is it. Dick was on that. Of the science members, when we had our GOA-ON meeting in Seattle in January of 2025, there's about 4 people on this original list of the science members who are still involved, a few more from the program representatives, and so a nice long career helping GOA-ON guidance. GOA-ON in 2025 looks like this. You've been seeing this map at our OA Week celebrations, the hubs, and I want to reiterate the importance of the hubs. Here's where the Executive Council really encouraged grassroots formation of these regional hubs to foster communities of practice. And one of those is the North American OA Hub. And so again, how does it happen when we think about GOA-ON North American Hub? One of the things I can tell you is that I couldn't even put years on this. For a long time, Dick was using NOAA cruises to not just monitor the coast off the United States, but to go up into Canada and involve those scientists, to go down into Mexico and involve those scientists, and have these strong international collaboration on the cruises that really, as we started to bring the hub together, so many people were already working together, and it's a true testament to Dick's efforts to really unite people. So Dick we have had co-chairs from all three nations. Dick was elected the chair, along with co-chairs from Canada and Mexico. We met up in Victoria, and I will just say at our last meeting, Helen Gurney-Smith from Canada is our newly elected chair, letting Dick officially step down and enjoy his retirement. Here is a page from that first meeting's agenda. And again, his second talk, Richard Feely. And I love one of the things he said, what kinds of best practices products would be most useful to the hub? And that's the thing that really impresses me about Dick. It's sort of not just we need this, what's going to be most useful, and gathering the community to rally around that would be most useful to the hub. Here's some pictures from our meeting in Victoria, in Mexico, and in Delaware. Dick certainly enjoyed being at all of those, as did we enjoy those gatherings. So in closing, I'd like to say, in the GOA-ON constellation, Dick Feely, you are a consistent star, and we absolutely thank you. And you're going to hear from people with their reflections and their thanks, but Katerina also has a kudos board for everyone to be able to sign in and share your reflections, because not everybody can speak today. All right, so thank you. And thank you, Katerina. And so now I'm going to turn to our reflections from around the world. And the first one to join us is Fei Chai. Over to you, Fei.
Hello, good to see everybody. And then I understand I have 5 minutes, and then I prepare a short presentation. So over the last 20 plus years, I had the privilege to host the Dick at the 3 different locations. And then each time I learned so much. We spent the time together, and then so that's not only, shape up my professional, but also my personal life. The first one was a Darling Marine Center, and 2002. And then there's back to J-Golf days, if you still remember. And then the second one was just the Dick traveling around the U.S. many universities promoting the ocean acidification. The last one was the fourth GOA-ON International Workshop in Hangzhou. Believe it or not, the picture, the photo, we used it, and it was from Hangzhou, because I hired a professional photographers, and then I will show you a few more of those. The first one was really 2002. The Equatorial Pacific, the modeling and synthesize workshop I hosted at the Darling Marine Center. As many of you, those the part can still see. That was a Dick, and back then, and then he stayed after workshop, and I was able to drive around with some friends. Of course, we have lobster bake. That's a McFadden in there. And then that led to actually another project we worked together called the biocomplexity in the equator. And then it was 2 years actually. Dick sent his technicians groups, and we still work on the equator even today, and on a lot of the parts. This is really the silicate story, the silicate limitation in that part. And then 2008, and Dick came to University of Maine, gave a talk, and then that was a Saturday, the April 19th. And then his flight, it was about 2 o'clock in the afternoon, in the morning after breakfast. Said, they said, Fate, why don't we just drive to your cottage? And we never opened the cottage, drive down that early. And we spent a couple hours and took some photos, but my car stopped. We couldn't get out of the mud. And then finally, my neighbors had to chain us up, and then I have to drive very, very fast to take Dick to the airport. And but Dick, I hope you will have a time to visit me in the summer and not that early spring. And so we still have the cottage where I spend my summer is. This 2019, the fourth GOA-ON International Workshop, 260 people attended from 61 countries and the regions. And then we had a big banquet and they gave a keynote. And then at the banquet and people get on stage, make toast. And I think Dick was very touched with this many people. And then some people say, well, we hear a little bit of emotion there. And so I think this is on the GOA-ON's website. This is the executive council. We had a meeting and after the workshop. And I'm so glad to see some of you here. I think there's three things I learned. It's really the passion for the ocean science, sometimes a little bit intense and ask the questions, and then, but the commitment to the mentoring early career scientists, and many of you are here. And most importantly, promoting international collaboration. In early days, you know, through the Pisces, I remember working with Toshi Sino and others from Japan and Asia to get all this CO2 data together. That was a really, I learned, I watched how Dick, you know, dealing with international collaborators and getting the data together and promoting the international collaborations. For that, thank you, Dick. And then I look forward to hosting you either in May or China. I may visit you, your lake house in Minnesota. With that, I stop.
Thank you so
Thank you
much.
very much.
Thank
He
you,
didn't
Faye.
he didn't tell you that when we got done with that car, we both were full of mud, and I had to get on the airplane full of mud.
That's great. That's a great story. Thank you, Faye. That was really excellent. And I know at some point you're going to need to go to sleep. So really appreciate you joining us at an inconvenient time to you. Okay, next we're going to hear from Katie Schamberger from the United States, a former student of Dick's. Katie, over to you.
Hi, can you hear me okay?
Yes, we can.
And do you see a slide?
Yes, definitely.
Okay, great. So I'm Katie Schamberger. I was lucky enough to have Dick as my PhD advisor. I was actually co-advised by Dick and Chris, which is the ideal combination for PhD advisors. I was very, very lucky. And when I was asked to say something about how Dick has impacted my work, the thing that kept popping into my head is that Dick has impacted all of my work. So instead of explaining my entire career to everyone, I just will talk about a couple big take-home messages that I've gotten, not just as Dick's PhD student, but over the last 20 years now, as a collaborator and mentor. To give you an idea of what Dick was like as a PhD advisor, we would have regular meetings and we would discuss whatever we needed to discuss, data, presentations, papers, classes, whatever. And then when we would finish, Dick would launch into what I started calling life lesson talks. And I called them life lesson talks because they were always something Dick wanted me to learn, to understand, that was bigger than just my PhD research. And in thinking about all these life lesson talks that I got while I was his student, I realized they all kind of boil down to the fact that Dick is a connector of people and ideas. I think this is one of the reasons his work has been so impactful and why we have people from all over the world here. He is constantly connecting people and connecting ideas, and that makes for excellent science. So one of my favorite life lesson talks from Dick was about how email is not sufficient for collaboration, that you have to actually talk to people. You need to set up a meeting or a call, and it's when you can actually talk with someone that you connect, that research ideas connect. And this is a lesson that I am constantly telling my own grad students now because they all want to text and email, and I force them to have conversations with people. And that's because Dick did the same to me. Another thing that was kind of a revelation for me as a PhD student was that I could contact people I didn't know. I could read a paper, have questions or thoughts about how that connected to my own research, and then I could and should contact the author and set up a meeting. And this, again, is another point where Dick is so good at reaching out and connecting people. And also, you should be reaching out across fields. And the first time I really got a lot of practice with working as part of an interdisciplinary team was really my PhD committee, which Dick constructed very intentionally. We had amazing chemical oceanographers like him and Chris and Paul Quay, but then we had Parker McCready, an incredible physical oceanographer, and Ken Siebens, who's a coral biologist. And I learned so much from this group. And to maybe the dismay of my collaborators, I am constantly harassing physical oceanographers and biologists about how my chemistry data makes sense with their different types of data. And it was really from Dick and Chris and the whole group at PMEL that I learned to be a good team member. This is really where it was impressed upon me that being a good team member means helping each other, even when the task might not be what you're specifically focused on. That good science gets done and work gets done when you're working as part of a team, and everyone's helping each other. And as a professor, I've always had a pretty small group. And so I talk with my students about this all the time, how we all have to work together, even though they are on different projects. And then I think the biggest thing that that I started learning from Dick as a PhD student, and that's continued for all of my career, is thinking big picture. He was always asking me, why does this matter? Why is this important? What implications does this have beyond the coral reef in Hawaii that my PhD work was on? And now I harass my own students with this same big picture thoughts when it comes to writing intros, giving presentations. I think Dick is kind of gifted at thinking big picture, and this is something I've been trying to learn and pick up from him over the years. So I was really, really lucky to have Dick as a PhD student. I am lucky to still be mentored by him. And I'll just end with a quick little picture. Lucky for me, he keeps getting awards. And where I'm at, Texas A&M gave him the Geosciences Medal earlier this year. And I got to host him and have him in Texas. And this is a picture of me with Dick in his award, and Siobhan Kassem, who did her master's with me and is about to submit a paper that Dick is a co-author on. So the publications continue. Dick, thank you so much for everything.
Thank you. Katie was certainly the most fun and lively graduate student I ever had to work with, and enjoyed her very, very much as a person, as a colleague, and as a very dear friend.
Thanks, Dick. Right back at you.
Thanks so much, Katie. That was just really beautiful. It's so great to hear about and inspiring to hear about how the things you learned from Dick then are passed along to your students. Okay, our next contributor is Carol Turley from the United Kingdom, bopping around the world. Hey,
Okay.
Carol.
Hi there. Thank you for inviting me to speak at this very, very special occasion. I thought I'd mention some more personal views about Dick. So to start with, Dick is a visionary. I think we're seeing that as a theme. Dick, do you remember the invited talks we both gave at the Heinz at Horizon OA soiree at the Carnegie Institute in 2012? And it was hosted by a lovely gent called John Kerry, who wined and dined us afterwards. Really
Very
spoiled.
much so. Very
Yeah.
much so.
Later, Dick said to me that these talks were probably the most influential, world-changing ones we would ever give. How true his words were. Just months later, that engaging gent became the Secretary for State and hosted the first Our Ocean conference in the State Department in 2014. There, the US announced $9 million for GOA-ON and $1 million for the Ocean Acidification ICC in Monaco. Also, I made a note to myself to check out the credentials of the host of meetings in the future. Secondly, Dick is a consummate professional. Dick's work as lead author of the IPC since, I think, around 2004. Correct me if I'm wrong, Dick. The AR4 was published in 2007, and the authors, members of the IPCC, jointly received the Nobel Peace Prize shared with Al Gore. And I'm not sure Dick would have predicted that. So, you know, he's not always on the ball. OA was mentioned in AR4 for the first time. Very few lines, but it was mentioned, it was raised. And Dick, amongst other scientists, wrote to the IPCC, governments, etc., to give OA and the ocean in general more space in the next assessment report. We proposed an ocean chapter in AR5 and a special report on ocean and climate change. Again, these came to light, but we ended up with 2 chapters in AR5, which was quite interesting. Next point is Dick is kind and supportive. We've attended many of the same conferences over the years. At the end of a long day, when the rest of us were heading off for a well-earned drink, I would invariably see Dick sitting in the conference room in a quiet corner, working on a youngster scientist's paper, job application, or research proposal. Many of us here today will have experienced his support. At one occasion, I mentioned to Dick that a UK artist friend of mine was having problems getting a special screw for a fitting for her art piece. He asked me to send him one, as he had a great hardware store down the road that could just get about anything. Next meeting, he handed over a bag of the screws, perfect. My artist friend still remembers his name and his kindness. Dick is rigorous, we know that, and brave. Dick is scientifically rigorous, making sure, especially in the early days of our scientific messaging, that our messages were correct and accurate. Dick, I also remember you courageously taking on the climate deniers, calmly, unflappably beating them with sound science. And Dick, you talk to anyone and you engage with international policy, which was so needed. You were willing to put the long-term effort in here too. This included talking to policymakers, funders, people in power and governments, the media, just anyone. We were both at COP15 in Copenhagen in 2009, and you have attended many more since then, where the ocean hardly featured in 2009. OA was featured there for the first time on the PMEL and PML stands. Now there is an ocean pavilion, tens of side events on the ocean, and the ocean is mentioned in the outcome documents of the COP since the Paris Agreement in 2015. Dick, I don't know if you remember, but you also attended the UN Rio+20 Earth Summit in 2012, participating in side events and many media interviews, with the summit's outcome document called The Future We Want, mentioning the ocean and ocean acidification, which morphed into the Sustainable Development Goals. And Goal 14 was on the ocean, with target 14.3 specifically on ocean acidification. The effort to achieve this was vast. And he didn't hang around in Rio. He headed straight back to Seattle for the first GOA-ON meeting, talking about getting all the ducks lined up. Dick, you have left an amazing legacy, both with your science and policy influence, and made many friends all around the world, some of whom here now. I am honored to count myself as one of them. Dick, my friend, I wish you a happy, healthy, and long retirement, and you can take it from me, life just gets better. Thank you.
Thank you, Carol. Carol taught me to be bold. She's the one who pointed out to me that there's nothing to lose. So she and I went and talked to the Secretary General at one of these COP meetings together. And that's actually how we got the ocean acidification into the IPCC process, by that individual talk. I still remember that to this day. And you just grabbed me, said, let's go do it. And we did it. It was amazing.
I think I might have said they don't shoot people nowadays. So have a go.
That's right.
Oh, thank you so much, Carol. That was just beautiful, and really appreciate that reflection. And just as a personal note, I have learned so much from you about COP and all of those processes. And thank you for being an amazing leader as well. Okay, our next person is Nina Bednarsik, and take it away, Nina.
Yeah, thank you so much. I thought that I'm gonna have slides, but I'm not quite sure about this, but we can go on with this. So good evening here from Slovenia. I'm Nina Bednarsik, and today I wanna honor not only Dick as a pioneering scientist, but also as a mentor whose guidance shaped much of my own scientific path, and with whom I've been privileged to conduct ocean chemistry and biology research across many years together. And that's why my talk is of the chemist and the biologist. Next one, please. I first met Dick long before I joined NOAA PMEL in 2009 at the conference in Princeton. And I was presenting early work on theropods and shell dissolution. And he approached me afterwards with that characteristic calm curiosity. He didn't talk about his own science, but he asked me a lot about everything what I knew about theropods at that time. How I measure dissolution? What about the carbonate chemistry? What are the organisms telling me about the ocean? And that brief exchange really planted the seed for everything that followed afterwards. When I arrived at PMEL in 2012 as his postdoctoral researcher, I stepped fully into his world, a world of extraordinary precision and quiet integrity, where carbonate system equations captured the invisible chemistry of the ocean. Dick's lab was the epicenter of ocean carbon research, and decades of his work at PMEL defined how we quantify and understand anthropogenic CO2 uptake and its chemical consequences for marine systems. Dick was already a legend, one of the chemists who taught the world that our ocean was changing its very chemistry, and long before it became a mainstream concern. As a biologist, my perspective was rooted in the visible: shells, tissues, stress responses, theropods, and other marine classifiers. Dick came from chemistry, from the world of carbonate ion and perfect balances. and somewhere between us, a bridge was built. What made Dick truly exceptional and what defined our collaboration in many, many different ways was his openness to cross-disciplinary boundaries. Long before interdisciplinary science became fashionable, Dick understood that chemistry alone could not tell the whole story of a changing ocean. He was one of the first chemical oceanographers to actively invite biology to the table, not as an afterthought, but as an equal partner. And what emerged through our collaboration was a synthesis between those two dimensions, how chemistry constrains biology and how biology in turn reveals the system functional limits. This became our constant dialogue and shared language, the chemist and the biologist, reading the same signal in different dialects, learning to translate each other's perspectives. In the years that followed, our work together from the US West Coast, Salish Sea, Puget Sound, the Arctic, and the global scales became about uniting those halves of the same truth. His careful mapping of aragonite saturation states gave context to the biological observations. When we combined those insights, the pictures became whole. Chemistry and biology were not two systems, but one story. Next one. Next slide. Our joint research demonstrated that when saturation state drops below species-specific thresholds, biological impacts became measurable, widespread, and ecologically significant. That integration of field chemistry with organismal biology changed how vulnerability to acidification was assessed. It was not merely a merging of data sets, but of disciplines, a framework that translated chemical exposures into biological consequences. We applied this integration across taxa, mostly theropods, yes, Dungeness crabs, oysters, and expanded it to include larger concepts of OA as a planetary boundary. Now, the same framework is guiding our research for ocean-based climate solutions, specifically ocean alkalinity enhancement. In many ways, we achieved more together than either of us could have alone. We published 35 papers together since 2012. And along the way, we managed to interact with countless journalists, policymakers, and managers, which was truly inspirational, and imagine how competitive this could be for Dick. Next one. But Dick's influence reached far beyond the data. He was an exceptional scientist, yes, but also remarkably humble, patient, and deeply human. He made space for others to think, to question, and to discover alongside him. He led without dominating and mentored without micromanaging. He didn't instruct, he led by example. He created space for ideas to mature and for people to grow. He listened even when he disagreed, and when he spoke, it was with precision, clarity, and kindness. He valued good science more than being right, and collaboration more than competition. He expected deep thinking, but treated mistakes as part of growth. Through that, he shaped not only my work, but my own approach to mentoring others. For me, working with Dick was transformative. He shaped not just my scientific toolkit, but my scientific character. Our joint work is a testament of how mentorship and collaboration elevate both mentor and mentee. What I carry most from his is his generosity, of time, of credit, and of curiosity. Thank you, Dick, for seeing potential, for challenging me, for walking so many miles of scientific path together. Thank you for reminding me that the best science is always a conversation between disciplines and between people who care enough to listen. And again, thank you, Dick, for the mentorship, for collaboration, the friendship, and for the ocean we try to understand together. And I know there is going to be more of science with Dick even after his retirement. Bravo, Dick.
Thank you so much. It means a lot. It means a lot. And it's been a wonderful collaboration that I'm very happy to have had with you over the years.
Thank you, Dick.
Thank you, Nina. That was a really beautiful and touching story, and so so informative. Like I said, I'm so glad that there will be early career professionals and even mid-career professionals listening to this and learning how special those tenets can be. All right, next we are going to Mexico to hear from Martin. Martin, the floor is yours.
Thank you so much. I'm going just to share maybe one slide that I have. I'm thinking it's ready just to link. Yes, what I can say that is living, teaching, mentoring. I was trying to remember when exactly I started to meet Dr. Philly. And I guess it's also about 20 years ago. I was in a meeting in a American Carbon Program, North American Carbon Program meeting, maybe in 2003, 2002. I presented a poster and Dr. Philly visited my poster, asked me about my work. I was working with a biochemical process of the carbon in a coastal lagoon. And at the end, he invited me to be in a meeting in NOAA facilities in Seattle. I mean, many others, excellent researchers. I met Chris Subine over there, Nikki Gruber, Burke Hels, and Dr. Takahashi was over there. I was so fascinated because these guys only read in papers, and then I feel like a red carpet, a superstar over there. And I was so nice and very pleased with this invitation with Dr. Philly, because I meet in person these guys. I was able to listen the presentation and also to chat with them. I was so pleased with that. And then in the meeting, Dr. Philly summarized his research about the published paper that Chris Sobine was talking about in 2002 about the omega aragonites was shown in the North Pacific. He also presented a comparison of the data of 2004 versus the 94 from the P220 from Japan to San Diego. And he was focusing on the finding regarding the changes of the depth of the omega saturation in connection with outwellings. And this was so nice to listen this approach. The hypothesis was maybe we have the problems. And after the meeting, came to me the invitation for the famous cruise from Canada to California, Mexico, and which resulted in the work of this published paper that's Dr. Science offer. After that paper, Dr. Philly asked me with interest frequently how things were developing in Mexico after this discovery. I must say that I began my journey in the field of CO2 system since my master in 1994. My goals was very similar to Chris Subine was talking about, was about the biochemical processes, CO2 fluxes, but my vision broadened after he invited me to this cruise, because both related with in reality, I feel like I did a degree thanks to him about the ocean acidification. With his explanation, didactic observations, contagious daily joy during the days of the cruises, teaching the interesting results we found. He used to share the experience very often during the cruise, during the day. In reality, this cruise marked the beginning of a wonderful friendships and collaboration that in reality facilitate the creation of the North American hub, including Mexico. In reality, as a representative of the Mexico, I truly wish that Dr. Philly have a lot of fun in this new chapter. At the end of the cruise, I asked him, if you accumulate, Dr. Philly, the month that you spend in the ocean, did you have several years? He asked me, of course. I did several years I did in the ocean. Several years that you can imagine, sharing, leading, mentoring. And I feel so pleased to be part of this international network that you did in these many cruises. Thank you, Dr. Philly, for your friendships.
Thank you. That first cruise that we went together on in 2007 made the major change in my life as well, because I began to appreciate how important it was to interact at the international level and work with colleagues who have similar interests and similar ideas about how the oceans are impacted by ocean acidification and climate change, and bringing the biology together with the chemistry, how important that was that we do that on every single cruise. And it was your cruise that really made a difference to me about that. We all joked about how much we were going to see acidification on that cruise, and we all were wrong. It was everywhere we looked, everywhere we went. It was there. That's when we realized how important it was.
Thank you so much, Martine. That's just a beautiful story of international collaboration and why GOA-ON is so important. But organizations don't make collaborations, it's people. And you both have done that just so beautifully. Thank you. Our next speaker is a former GOA-ON co-chair, Bronte Tilbrook from Australia. Bronte.
Hi, thanks. It's a real pleasure to congratulate Dick on his retirement, and I want to really point out just how important Dick's been in advocating for carbon cycle research and in the ocean and ocean acidification research. He's been a mainstay. He's been at the heart of many of the developments that have occurred in the field, and we're internationally really grateful to him. He's been on, I saw it from his CV, over 60 cruises. He's published hundreds of papers. He's been on a huge number of committees, and we spent many hours talking at weird times, trying to connect over internationally. And I've really appreciated all the influence he's had and the input. He's quite a remarkable person. The other thing, though, it's easy to quantify from a CV, a number of publications. It's really difficult to quantify just how important Dick's been to develop the careers of so many people around the world. GOA-ON's just one example with, you know, there are thousands, over 1,000 people now in GOA-ON, and many of them will have had a career, been able to develop a career because of what Dick's been able to achieve and push. And really appreciate that, including my own career. He's been largely responsible. So Dick, you're responsible for a lot of people and families around the world. Really, and the community, I think it's really tough to get that across to people, just how important that is, given opportunities. So I've known Dick for just over 40 years. I don't know if he remembers, but I met him on a cruise in the North Pacific. It was a cruise operated by Dick and Peter Betzer. It was a look at dust input from Asia into the North Pacific affecting fluxes. And I was a graduate student at the time at the University of Hawaii, and Dick was a young researcher at NOAA in Seattle, and he'd actually published a few papers in the early 80s on aragonite saturation states in the North Pacific, and they were really fascinating papers to me. I really wanted to work on that. I didn't have much of an opportunity, so I was really looking forward to going out on the cruise and meeting Dick. And the cruise was interesting. It was pretty rough. We spent a lot of time indoors, not being able to work on the back deck, collect samples. But and when we did, in those days, there wasn't much to do on a ship. You could either read a book, sleep, or play cards and wait for meals if the weather was rough. And we played a hell of a lot of cards, I think up to 12 hours at a time, waiting for the weather to clear. And I came to know Dick for what he really is. And many of the people described here, he's a really nice person, a humble person, knowledgeable, and he's a bloody good card player too. I couldn't beat him. I tried so much to beat this guy at cards, and it was just impossible. I gave up in the end. Well, I had a really nice time on that cruise. It was very educational. It was great to meet him. Then I kept in touch with Dick and saw each other a few times at meetings. And in 1990, I was given an opportunity to go back to Australia and start measurements of CO2 in the ocean, which was not done at that time in Australia. And Dick was really, and colleagues at NOAA were really instrumental in us being able to develop what I think's been a useful contribution to ocean carbon cycle and ocean acidification research, at least in the Southern Hemisphere. And I really appreciate all the influence he's had in my career. I've, things like his advocacy for the waste JGOS deep ocean sections, which are now GO ships, and the surface ocean CO2 observation networks, have really been at the core of understanding ocean acidification change and ocean carbon cycling. So, Dick, I really appreciate that. I've learned a lot from you, watching you. I've been on so many committees with you and had the pleasure of discussing issues with you. I really congratulate you on retiring, and I know that you're a gentleman of leisure. I'm hoping that you're going to get an opportunity to continue working in the field, less management, something that everyone looks forward to, and getting to focus on what you're really interested in. And it's just been such a pleasure to have known you and to continue to know you. I hope we see you in Hobart someday. Thank you.
I hope to be able to get there. It'll be wonderful. We've had a wonderful time. I stayed at Bronte's house the last time I was there, and we've just had such a great relationship. And it was really amazing to me to be able to extend our community all the way to Australia and build that GO-ON program together over the years. This is the beauty of the collaborations we've had over the years, is the fact that we had developed a family of scientists that were willing to work together on big, important problems together and make a difference to society.
Thank you so much, Bronte. That was beautiful. And as a seagoing oceanographer, I especially appreciated your relating, what it's like to be on ship, and how it just brings out that humanity and cutthroat card talents as well, but all in really good fun. Thank you, Bronte. Okay, so we are going to leave Australia, go to Korea, and Kitak Lee, over to you. Thank you.
Okay. Before I share three personal memories about Dick Feely, I'd like to say big congratulations to your very successful scientific career. The first memory that I like to share with all of you goes back to in 1989. I'm not quite sure whether Dick remember this one, but that was my first meeting with Dick Feely in St. Petersburg, University of South Florida, where I was working for my master's degree, not about carbonate chemistry. My advisor was a Bill Sackett, who happened to be a Richard Feely's PhD advisor. And then I explained to him about my silica work. I was deeply involved in a quantification of marine silicate in marine sediment. And then probably about 5 or 6 years after that, I talked about him and reminded him of saying about my master's work. But he told me that I didn't understand what you talked about, because probably there was my first year of American life, and my English was really bad. And then after the first meeting with him, I thought that I probably may not see him again, because I moved to St. Petersburg to to University of Miami for my PhD. And I worked with Frank Molero for about 5 or 6 years. And then there I was involved in the internal consistency work. And I reunioned with Richard Feely in Puerto Rico in 1996. There was the first CO2 in the ocean. I had a great chat with him during the meeting because there was a lot of outdoor activity excursions. And then I still remember that he was the first person talked about the ocean acidification work. At that time, as Chris Sabine mentioned, that term was not officially accepted. So he emphasized the importance of the ocean acidification work. And then I was puzzling at that time. Then what should I do after I getting a PhD? And then that was the turning point. I started thinking very hard about the ocean acidification research. And then, but that truly influenced the entire my scientific career. But ever since the second meeting with Dick Feely, I have about more than 20. I haven't count accurately, but I have more than probably about 20 calls or paper with him. I'm very proud of having those scientific communications with Richard Feely through writing papers together, and then he tremendously influenced and shaped my scientific career. There are 3 people that influenced my entire scientific career. Is Frank Molero, who was my PhD advisor, and then second person is the Rick Wonokoff, who was my longtime friend and then postdoctoral advisor, and then Richard Feely, and then he truly shaped my scientific career. And then I also greatly appreciate Dick Feely. He has been supportive for my tenure promotions and AGU fellows. I really appreciate your constant support in my scientific career. Thank you.
Thank you. It's been a joy working with you over the years. And I remember that meeting with Sackett we had way back then. That was an amazing meeting. I enjoyed that. One of the few times I was able to be with Sackett at the end. Yeah.
Okay. Yeah.
Thank you so much, Katak. Those are really beautiful memories. And again, all about mentoring and friendship. So well put. Thank you. Okay, we're going to hear from another former GOA-ON co-chair back to the UK to hear from Phil Williamson. Phil.
Hello, good day to everyone. And thank you very much, Jan, and everyone else for the organisers of this meeting to invite me to be here. I'm somewhat of an odd one out in that I don't have a sort of great research history of my own. I suppose I'm representing the research funders and the programme planners and the sort of the other communities that Dick's interacted with and helped foster and inspire. And I'd like to sort of frame his contribution as a sort of 4-dimensional one for ocean acidification research, that he, right from the start, it was as a chemistry problem, it was a spatial variability, but it was also the depth problem of changing with water depth, but also changing with time. So you've got those 4 dimensions for the science, for the research, but you've also got those 4 dimensions for the researchers and the community and the wider world that we're involved in. You've got the geographical connections across the world that helped, as we've heard, foster and encourage and inspire. We've got the depth of understanding, which involves the interdisciplinarity of bringing together the biology and the chemistry and the social science and the politics and everything else of those different layers of science that is involved in ocean acidification. And you've got the time dimension, which is the most important. Now, we might have met in the 1980s or the 1990s with Jay Goss, because I did have some involvement with that. I'm not sure. I've been to a lot of meetings If it's saying if you remember the 1960s, you weren't there. I'm not sure whether I remember all the meetings that I went to in the 1980s and 1990s. I think I'll start off with the one when Dick really gave a very significant impression for me. And I think it was from a different perspective, sort of seminal and influential for ocean acidification. And that was from program management point of view. It was the 2010 meeting when we had the UK Ocean Acidification Programme having one of its first meetings, but it was also one of the first meetings for the German bioacid meeting, and it was the second meeting, I think, of the European EPOCA, European Project on Ocean Acidification. And Dick was one of the international advisors for that meeting. So we were in Bremerhaven in Germany, had all the Europeans together. Now, there was a lot of talk about the biological impacts there. Now, and this was 2010, so ocean acidification had been going for quite a few years. I'd heard about it, I'd known about it. I was involved with Carol Turley in helping to initiate and start the UK programme. Having Americans there as well at our European meeting, to me, it sort of epitomised the international dimension. The fact that we'd had the Venice meeting and the Paris meeting, it really brought it together. This was something, and it was to a certain extent sort of a grassroots from the bottom. There was IGBP behind us. There was others, international bodies interested in us, but it was actually something that we were doing ourselves and meeting and talking and getting it together. And Dick's sort of perspective on the biological experiments was saying, well, there's the chemistry and you've got to understand this, you've got to link with that. And there's a whole lot of group of people in America doing much the same thing. And so that 2010 meeting, to me, helped in some way. I mean, the success has many parents, but that 2012 Seattle get-together for GOA-ON setting that up, it was sort of the awareness that there was the wider community out there and that there were people who were helping to drive it and put it together and put the pieces together. And I was there as a funder, and okay, I didn't have all the money that I wanted to bring from the UK, but I knew that if we had some good ideas, that I could do a follow-up meeting, which we did 2 years later. And so it's sort of the jigsaw, the catalyst, the putting things together that Dick was very good at, and that we all success has many parents, but Dick, you're the grandfather of that success, and help inspire, but also, and it's been mentioned already, the rigor, the data management, that was absolutely crucial for that Seattle meeting. I think it was built on some data management plan that the US had put together as a sort of model to say, if you're collecting lots of information from around the world, you've got to know that it's have that intercomparability, to know that someone else's data, you can believe in it, and to have that credibility, to have that rigor, to have that strength. All this was driven by Dick. So it's the time of day in the UK when I'm not quite sure anyone else has got a glass to raise, but I'm raising a glass to Dick to say I've enjoyed a good meal earlier tonight, and good health to Dick. Lots of whether it's prohibition in some countries or not, I don't know. But well done. Thank you very much. I've jumped in and out of ocean acidification. I follow your work. I read your papers. You continue to inspire, even though we might not meet on a weekly or a monthly or a day-by-day basis. Many thanks, Dick. Well done. Congratulations.
Thank you.
Thanks.
And it certainly was a pleasure working with you and Carol and in making that international connection work. And the connection with the policymakers was the key to all this. And you were the leader in that aspect. I really appreciate that.
Thank you very much.
Thank you, Phil. You've brought such great contributions, and really, it's great to hear from you and your perspective, which is absolutely so important. So our next speaker is Samantha Sidlecki. She might be riding or driving a car, listening to us, but she recorded a message because it's not good to drive and toast at the same time. So Katarina, if you could start the video from Sam Sidlecki from the United States.
Hi, I'm Samantha Sedlecki, and I'm an associate professor at the University of Connecticut. I wasn't able to join you there live today, so they were gracious enough to let me record a message to express my gratitude to Dick for his inspiration all these years. I first met him at C. So I was a student that was invited to be a CTD technician on one of the repeat hydrography cruises, specifically P16 North, in 2006. And I was a PhD student at the University of Chicago at the time, and my advisor suggested that I go out and get some field experience because I was doing idealized modeling, and he wanted me to observe that there was not a grid on the surface of the ocean. So and you know, learn respect for how people make observations. And so in my position, I was able to shadow both the chief and the co-chief scientists on that cruise quite a bit. And Dick was the chief scientist on that cruise. So he taught me a lot, and actually over the 30 plus days at sea that we were on that first cruise, he gave us problem sets, those of us that were in the technicians, like every day, to solve from the data that was coming in real time, which was super fun actually. And then we spent time at the end of each shift kind of talking through the problems, and the other students and I worked on them together, and it was I learned a lot. It was also kind of an instrumental cruise because it was the first time that the anthropogenic that they were looking for the anthropogenic signal in the North Pacific and found it. And so it was incredible to be there for that moment on the boat and to see the data coming in and see Dick's reaction to that. I have a little picture here from that cruise, which I took of Dick on the deck here, collecting some samples from the Rosette, which I have in my office as further inspiration, both about learning. I learned so much, and really valued that time. I was very influential that time period in my life. I think over the years, then once I finished my PhD, I worked towards getting back to Seattle to work closer with that group at PMEL, and Dick helped me to apply for the fellowships and pursue that work because I wanted to work on ocean acidification more. And one of the things that I learned once I was a postdoc at UW through GOA-ON jointly with PMEL, I was able to attend the PMEL group meetings, and Dick has over his whole career, right, worked on large collaborative teams, and it was an honor to shadow him in that space and learn about how he coordinated under large groups of people, all the different personalities and the scientific interests, and made sure the communication was strong across. So the beginning of every group meeting, he would start out with everyone go around the table and say what it is you're interested in working on this project, so that everyone was clear. And I really have learned a lot. I valued that experience and have brought that into my own leadership now of larger groups, as I think it adds a lot of transparency and helps coordinate all the various aspects of people's interests, scientific interests, towards the end goal. So I guess I just wanted to take this moment to point out a couple of things that I really value, and from my personal experience with working in collaboration with Dick over these years. And so thank you for that, and express my gratitude to all of your hard work, because there was a lot that I mentioned that was extra there that wasn't required. So thanks for going above and beyond, and I hope you have a happy retirement.
Thank you. Thank you.
Thanks, Sam. I hope you're listening to us, and just really want to thank you for recording that. And I love how Dick has always worked as a fundamental ocean observer, but very strongly with the modeling community. And to talk to us next is another modeler, Nikki Gruber from Switzerland. Nikki, so glad you're with us today. The floor is yours.
Thank you. Thank you so much, Ian, for organizing that, and a big cheers to Dick right away. And also thanks to all the other speakers to already raise a lot of exciting and special things about Dick. So let me add a few things also from my side. So I have essentially 3 adjectives that I have for you. The first one is compassionate. You're a compassionate scientist. The second one will be you're extraordinarily supportive scientist and person and mentor. And I think perhaps also that's not unimportant here, you have been incredibly persistent. And let me explain all of the 3 adjectives a little bit. And you're really a compassionate scientist. I've heard this a lot from, because I mean, working with you, you're immediately grab people's attention. You're interested in what they do. You bring people together across boundaries, and you literally don't know boundaries. I mean, maybe some of you don't know, but Dick really started actually as a really hardcore geochemist working on black smokers and aragonite. We heard this from Bronte, sort of thinking about dissolution processes in the deep ocean. And gosh, where has he developed? There's hardly a field that he hasn't touched, I think, in the broadest sense. And I think that has only been possible because of your deeply genuine interest in scientific questions across the board, and bringing this compassion it is to actually work with people and bring the best out of people. And I think that really made it possible for you to be so successful. And I think in that way, you're an absolutely role model for me, and I think for many of us. So how do you do this? How to work and be a leader? At the same time, you're somebody that really works together with people and embracing their skills, but also their love in some sense. And continuing on this note, how supportive you have been. You may probably not remember, but I met you the first time again, similar as Kitak Lee, actually, in 1996 in Puerto Rico at this first CO2 conference. And I was just have gotten my PhD at the time. And I worked on the anthropogenic CO2 in Kitak Lee and knows exactly what I'm talking about. At that time, it was a very difficult topic because you had a giant in our field like Cold Wally Brooker who felt that this is bullshit. I'm not exaggerating, and then I gave the presentation on this work that I was doing at the time, and they came to me, "Well, that's great, that's absolutely lovely. We need to use it. We have these data. We're going to work with this." And gosh and behold, I mean, this was essentially the start of all this work that Dick and then also, of course, Chris Sabine took the leadership on. And all along, I mean, he took me along. And one thing I'm extraordinarily grateful to you, Dick, because you also brought me in the whole planning efforts for the CO2 repeat hydrography program. And you also, I mean, maybe not directly, but definitely very strongly indirectly, you made it possible for me to actually go on the cruise as a co-chief, and here a modeler out there as a co-chief on the NOAA ship. Well, that was an interesting experience, but it was a great experience, a lovely experience, and I think you get a lot of credit from me because you have always supported the young scientists to push them forward, to embrace them, to help them, and I think at that time I benefited enormously from your support. So thank you for that. Last but not least is persistence. I mean, gosh, I mean, you talked about GOA-ON, but I mean, you can go back and maybe one sort of decade earlier. The whole issue of bringing actually the repeat hydrography program on board, and Dick was co-chair of this. And I mean, how persistent he was. I mean, you couldn't go to a meeting and he was talking to everyone about for the funders, to the scientists, to who knows what, to make sure they understand the importance of making these measurements and making them well and precisely, and making sure we have the reference materials. everything, but also the funding. I mean, he was on topic and persisted on, and that's exactly what he brought on also later on to the GO-ON program and make it such a big success. So the GO-ON was maybe even the third sort of episode of where you really made a big difference to a large field. And I think what is currently the GO-SHIP program, I think would not have been possible without Dick, you putting enormous amount of effort. And just the last episode on Dick sort of not letting go. So, I mean, it's only a few months ago, we said, oh, well, we need to do this work on ocean alkalinity enhancement on the California current. Well, you have a model, let's do this and go on and work with some master student in my group. And, oh, great, we do this. And this is passion, and not only compassion, it is passion. And I think it's this passion that I wish you continue into your retirement. And because I think for us it will be a big loss if we need you still, Dick, in one way or another. I'm sure we'll find a way to keep you busy in our world. And thank you so much for everything you've done to the carbon cycle community.
Thank you. You know, I have to say I credit all the vision that we have from ocean carbon and ocean acidification from your early work with developing the approach for determining anthropogenic CO2 in the oceans. That's what made the difference, and that's what provided the vision for all of us to go forward and develop these programs in the future, because we really knew that we could connect the impacts that we are seeing with the anthropogenic signal itself. And it was your work that made that happen.
Thank you.
Thank you, Nikki. I really appreciated a lot of that history that you provided there, and those adjectives are so spot on for sure. Okay, gang, we have 3 more, but they'll be a little bit quick. Masao Ishii couldn't be with us, but he recorded a message that Katarina will share with us now.
Hi, I'm Masao. Now I'm feeling great loss to hear that Dick is retiring. All of you are feeling the same, I believe. I'd like to express my sincere gratitude and also big congratulations to Dick for his great works he has done for a long time. In the late 1980s, I moved from a study of physical chemistry in laboratory to marine research. Since then, for over 35 years now, and across the vast Pacific, I've been inspired by Dick's works and his strong passion for observational research into ocean carbon. I remember in my early days as a seagoing oceanographer, a paper that Dick published in JGR in 1987 impressed me a lot. It's here. The title is Distribution of Chemical Tracers in the Eastern Equatorial Pacific during and after the 1982 to 1983 El Nino Southern Oscillation event. This paper is a pioneering work that clarifies the strong impact of ENSO on ocean carbon in the Equatorial Pacific. Needless to say, this work and his following works have made a profound contribution to our understanding of the large variability in air-sea CO2 flux associated with ENSO, which are commonly recognized today in the global carbon cycle. Dick, I'm really honored to have worked with you and enjoyed in the 1990s at JGOF's ECPAC, and later at many other projects such as Global Carbon Projects RECAP, IOCCP, IPCC, and GOA-ON. I hope you stay healthy. And if you have a chance to come to visit Japan for sightseeing or other reasons, please contact me. Thank you very much. Bye-bye.
I certainly will. I certainly will. We've had an enormously successful relationship over the years, and I really appreciated the fact we were able to bring together our colleagues from Japan and the United States and Europe in Australia to combine our data sets in the meaningful ways.
It's so great to hear from Masao in Japan. And now we're going to head to South Africa to hear from Pedro Monteiro, who unfortunately, when he woke up, wrote to me, he says, I am sick as a dog, but I want you to share this with Dick. So I'm going to share his thoughts on a slide here. All right. So on behalf of Pedro, I will say what he wrote. Dick is the archetype of the proverbial shoulders of the giants on which we stand metaphor. He provided those shoulders with generosity, grace, and science rigor. We are all very appreciative of not just what he did, but as importantly, how he did it, because he set the example. More specifically, I really enjoyed working with Dick in IPCC AR6 Working Group 1 when he was the lead external chapter reviewer of the Carbon Chapter 5 that Pep Canadell and I were CLAs of. His engagements and suggestions were so insightful and considered. We really enjoyed these discussions, and we ended with a better chapter for it. Dick, I wish you well.
Thank you so much. That was a wonderful time that we got to actually really dig into ocean acidification in a very meaningful way in that report. And it was a very, very engaging effort because we were able to bring together Masao's work and other work in a way that was really representative of the importance of ocean acidification in the IPCC process.
That's great. And Pedro, we hope you get better soon. Okay, our last international reflection comes from Canada, from Wiley Evans, and it is recorded. He was also unavailable, but Katarina has the video.
Hi, my name is Wiley Evans. I'm with the Hakai Institute in British Columbia, Canada, and I'm very grateful to be here today to acknowledge Dr. Richard Feely, affectionately known as Dick, to those of us in the field, for all of his support, for me as a scientist, but for our institute and for the work that we're doing in British Columbia. Thinking back, I took this job here at the Hakai Institute in late 2015. At the time, I was a researcher at the Pacific Marine Environmental Lab, working alongside Dick and others there. And when I announced I was taking this position, Dick called me into his office and explained some of his thinking about how I should develop a team, how we should integrate ourselves with the ocean science community in British Columbia, how we should maintain collaborations along the West Coast. And those early discussions with Dick have been really informative for me and my thinking with regard to all of those aspects of our work, of our internal team dynamics, of our collaborations across teams, and just trying to really be a supportive and productive member of the ocean observing community along the West Coast. His influence on our work didn't end there. 2016, I was fortunate enough to be part of the West Coast Ocean Acidification Cruise. The image behind me is a drone shot taken in the Strait of Georgia during that cruise. You see the Ron Brown there, and next to it is our small research vessel, the Explorer. We were very fortunate with Dick's support to do co-occupied station sampling in the Strait of Georgia and on the central British Columbia coast. And then this effort was really important for us to understand not only uncertainties in our data through collections I additionally made over the course of the cruise, but also issues that were sort of plaguing us with regard to our sample collection from these small boats. Specifically, we don't have a CTD rosette. And so knowing precisely where we were getting our water from was an issue that we had to work out early on. And it was these comparisons with NOAA that was very informative for us to develop a workflow that allowed for that information to be achieved. And so that was hugely informative for our program and in helping to ensure high quality information that's coming from our science. Dick's influence in our ocean science and British Columbia's ocean science in general, it didn't, of course, end there. A number of years later, British Columbia moved to develop the Ocean Acidification Hypoxia Action Plan. And Dick was very informative early on in the development of that plan as we were meeting to define the state of ocean science, ocean acidification research in British Columbia. He provided, of course, the important West Coast context that he's been developing over the years, along from the West Coast ocean acidification cruises and from the NOAA moorings and other observing activities along the coast. And that was vital information to help set the stage for the development of the action plan that we are in the process of implementing in various ways today. So with that, I really want to say thank you, Dick, for all your support through the years, and I wish you the best. And I hope I still get to engage with you as you move into retirement. So take care.
I would love to have that engagement continue on. You know, Wiley, when we were on that cruise, he picked all those stations himself in the Straits of Georgia. So we were interacted very, very closely together. And then a couple of years later, the first North American hub meeting was hosted by Wiley in Victoria. And that was one of the most successful starts for our hub that really got us going in the right way. And he just did a tremendous job as the local host for that meeting.
Dick, I'm so happy that we were able to bring voices from around the world. There's so many more. Join the Kudos board. But the last thing we want to do is to hear from you. And I'm not going to take time to introduce you because you need no introduction. But I want to share with everyone, when Dick sent me his slides, he said, I want to stress the importance of everyone's role in contributing to the global understanding of the processes and impacts of ocean acidification. And everything you do, Dick, exemplifies that. So let me start your slides and the floor is yours. Oops, did that backwards.
Well, thank you, Jan, and thank you, everyone, for this lovely tribute. It really heartens my soul. And moving into retirement, you really get a strong feeling of what that community means to you over the years. Chris Sabine said early how I had thought I was going to retire 20 years ago. The reason why I have never retired over this past 51 years is because I've been so close to this community and enjoyed my life so much with this community that I just couldn't leave the work. And felt very, very strongly. You guys, all of you were my professional family, and I love you dearly, all of you. What I wanted to do today is to provide some perspectives on how we got where we came from, how we got there, and some of the lessons learned along the way. And I'm going to do this by showing primarily our global ocean work and how that relates to all the activities that we do within GOA-ON and the connection between the global work and the local work and the importance of that connection. Next slide. This is the GOA-ON Explorer image from the GOA-ON data portal that Jan hosts in the NANOS website. And it shows an example, just a snapshot of the kinds of measurements that we have been taking by combining the global ocean carbon observational efforts, both for SOCAT and GLODAP, along with all the coastal work that we have done being developed through the GOA-ON data portals. And what we did when we imagined this, we thought that when we developed the GOA-ON program was to meld these two together, to bring together the global observations and the coastal observations into one large database that we can actually keep track of, monitor, keep track of, and quality control every single data point such that the users who are providing the data have access to all the global data sets and then can use that in their own work, as well as be able to compare their results with their colleagues' results throughout the world oceans. And this was a big undertaking, a major task that we developed from the first GOA-ON meeting in Seattle. And it was the vision that we had all along. And it was a vision that was, as I said earlier, was derived from the understanding that we have developed the capability to determine the anthropogenic CO2 in the oceans. And from that, those anthropogenic CO2 measurements and analyses that Nikki Gruber and Chris Sabine showed us how to do, we were able then to delineate the processes that related to humankind and how that related directly to the biological studies that we were doing in major ways. And we really felt that this was the way forward. So by adding in the coastal measurements through the GOA-ON network, by combining the data sets through our national data centers and through the different data portals that provide data into the national data centers, we're able to amass a global data set that now amounts to 40 million measurements throughout the world oceans over the past 60 years. So it's a tremendous accomplishment that we have made by working together as a community. And each and every scientist that have provided measurements into these databases are a major component of this effort. And I really strongly suggest that we continue to maintain this global database and expand it and develop it further as much as we possibly can. And as a community, realize the global importance of this. And as we were saying, as Jan said in the very beginning, carbon dioxide is increasing in the atmosphere, and the role of the oceans in taking that carbon dioxide may be changing over time, and we need to understand those changes, and we need to understand the biological implications of those changes. So we have a big challenge before us. Next slide, Jan. Way we approach this from the very beginning within the GOA-ON is to say we have two different quality sets of data sets that we have. We have climate quality, those that allow us to calculate the anthropogenic carbon conditions in the oceans, and the weather quality measurements, those that allow us to understand variability patterns and their impacts on the biology. And what our challenge was to combine those two data sets in a way that we can utilize them together. And to do this, we went to the data centers and asked them to help us to provide quality control from all the data sets and control and develop a quality control measurement for each of the samples so we know how we could utilize them on all our different experiments. We did this through the efforts of SOCONET, collecting the samples, and GOSHIP, collecting the deep water samples, getting the data together in SOCAT and GLODEP, and combining that with data input from the GOA-ON data portal, the SDG 14.3.1 data portal, all into the data centers, and then evaluating each of those data sets and then providing them to the community so we could look at both global and local distributions of the chemical parameters and incorporating all the biology in this work. And a major emphasis that we've had is co-collecting and co-designing experiments, co-collecting data between the chemistry, the biology, and physics so we interpret the data correctly. Next slide. This is an example of the kinds of data sets that we were acquiring over the years, starting in the 1960s and going out to the 2020. As I said, we're now up to 34 million data points. The cyan colors are all the surface measurements we collected for each of those decades. The red lines are the surface to bottom measurements from GOSHIP and the WOS hydrographic programs. And this has been a tremendous effort internationally to work together to provide the data sets and get them into the data centers so that it has equal access to everyone throughout the world. And by the collective efforts of all these communities, we're able to continue this into the present. And I'm very proud of the fact that we are continuing into the next decade of measurements in the next several years. Next slide. Now, the approach that we took for particularly, for example, with SilcoNet is to use the observations that we get from the field, from the shipboard measurements, from the floats and gliders, from moorings, combine that with temperature and chlorophyll maps of satellite data, and use that along with an algorithm that was developed in part of the SilcoNet program, here shown by the work of Rick Weinikoff and his colleagues, to provide monthly maps of the distribution of PCO2, from which we were able to calculate hydrogen ion concentration, pH, and other parameters as well, and get the fluxes of carbon on a monthly basis. And we've been doing this regularly, and this is the information that goes into the IPCC reports and allows us to see the year-to-year changes in the carbon uptake of the ocean and how those changes are occurring over time. Next slide. And because we have been able to collect large amounts of data over the last 50 or 60 years, we've been able then to make comparisons between the observations themselves and the models. And this has been a major effort that we collectively as a national, international community have done. We take the observations and provide, in this case, decadal differences between from 1960 up to the present, and allow us to get at the mean decadal averages for each of these decades and look at how the trends have occurred over time throughout the world oceans. Again, this is just a tremendous effort by everyone who's making measurements out at sea and providing not only the open ocean data, but the coastal data sets as well, and contributing to the complete understanding of the sources of sinks of carbon in the oceans. And doing so, we're able to do the same thing for pH and carbonate ion concentration or rag ion saturation and so forth. Next slide. And this allows us then to make a comparison between how we are doing between the observations and the models, and the blue and red lines represents the model outputs from the beginning of this effort out to 2050, and it shows how different CO2 emission scenarios allow us to understand the changes that have been taking place. And the columns, the vertical columns, show the mean for each of the decades for the carbon parameters in the surface ocean. And that shows that there's been tremendous agreement between the models and the observations thus far, and gives us great confidence in predicting the changes that we might expect to see in the future. And from that, we're able to see that, yes, indeed, over 50% of the changes that we see in the oceans have occurred over the last 50 years compared to the previous 200 years. So we are accelerating the changes and the rates of changes, and we can use both observations and models to determine how these changes are occurring in the oceans. Next slide. And here's where we then develop some confidence in the long-term changes based on the model outputs. And this is an example of the difference in pH from 1980 to 2100 based on the model outputs. And that allows us to see what kinds of changes will be taking place in the future using different CO2 emission scenarios. And we can see the large-scale changes are different regionally. And so we need to know how these changes might take place, with the smallest changes occurring in the tropical Pacific and tropical regions, and the largest changes occurring in the high latitudes and in the subtropical regions as well. And that allows us then to develop our our observational programs in order to address these issues about how these changes might take place and continue to compare the observations and models to see how well they will proceed in the future. And there is a very important concern as to whether or not the oceans will continue to take up carbon dioxide commensurate with the atmospheric increases. Some of the most recent publications from the GLODAP data sets have suggested maybe the oceans are slowing down a bit, and that's why the atmosphere is accumulating more CO2 in the present decade than it did in past decades. And so this is a major concern of how the oceans respond to climate change and respond to increasing inputs of CO2 into the atmosphere. Next slide. We've gone even further with that. Not only have looked at the chemical changes, utilizing the observations and combining that with the models, but even more so, we've gotten even more clever with the modeling efforts and with Nicky Gruber and his group and combining the ROMS model with the Beck biogeochemical models through Nina Benarsic and her efforts with the modelers in that group have been able to say, let's look at the sensitivity of ocean acidification and put that into the model and see where we can predict where we might expect to see significant ocean acidification changes in the future in the global oceans, and where we might expect to see changes that we can begin to monitor. This is an example that output from that work in which the top panel shows the average 0 to 100 aragonite saturation values over the global oceans. And in the bottom panel is a prediction of the impact of the changing aragonite saturation state on the pteropod dissolution that would be occurring. We've had a lot of supporting information from the Arctic Ocean and the Antarctic Ocean that support these measurements. But even these observations have extended our vision of what might be occurring that we in places where we have not been able to make the measurements of the biology system as yet. And as you can see, the eastern boundary upwelling regions particularly have very strong impacts, as strong as what we see in the higher latitudes. And even the tropical Pacific, we are expecting to see very strong impacts in areas where there's almost no measurements. And this is an example of how the models can provide us with information and predictions that we can then design experiments to study. And so for the younger scientists who are here today, I want to really recommend strongly that looking at models, outputs of what the biological impacts might be, looking at the impacts on the chemistry, and being able to predict what the situation might be in the future is a very good way to help design your experiments in your region and help design how you might want to develop your time series studies and develop the future experimental capabilities that you would have both in chemistry and biology. Next slide. This is an example of some of the newer technologies that we would want to bring into the carbon observing system of the global oceans. Sail drones have a great capability for covering large distances and making very sophisticated measurements in surface waters. And BGC Argo floats now is able to do surface to deep water concentrations of oxygen and nutrients and pH, and therefore we can help define the carbonate system from these profiling floats. And new in the horizon is things like C-track systems, which are AUVs that can do CDD cast down to whatever depth that you want through automatic processes using sensor technology that can be totally controlled from your laboratory. And so integrating these newer technologies that'll provide thousands and thousands of higher measurements and higher density measurements and integrating that with the existing approaches that we're using now, that's one of the great challenges. And the challenges for the chemists and biologists to add in the biology into these kinds of measurements and provide us with the information on sensor capability, calibration, validation, and how we can integrate these data sets into a more cohesive picture of the temporal and spatial changes of the carbon system. So we have great challenges before us, and we have a great setup in place for making these measurements and continuing these efforts because of GOA-ON and SOCAT and GOSHIP committing themselves to making these measurements well into the future. Next slide, please. So the lessons learned that I want to pass along to you is that we need to keep moving forward. We need to have that energy of this community moving forward to increase the density of the global carbon measurements and then integrate them with new existing and new technologies for chemistry and biology. We must support and maintain worldwide access to the global data sets and continue support to that with regional and global data centers are interconnected and the data comes in so that we have universal commitment to maintaining these data and providing them to the entire community. We must continue to provide synthesis and data products that are co-designed by end users. And Jan gave a wonderful talk yesterday of how important it is to involve the stakeholders and end users on how we design our experiments in the future and how we design our data products in the future that will meet their needs. We will only be successful in maintaining the observational program as long as we interact very strongly with our policymakers and our stakeholders in a way that allows the public to understand how important these measurements are. We must continue to promote capacity building and mentoring throughout our community. The discussions this week about capacity building is really heartening. It's because of the capacity building that we've had over the years that extended ourselves so that GOA-ON is now up to 1,200 members throughout the world. And by bringing in folks from other countries and helping them learn how to make the measurements, now we're helping them at the community level, we're helping them at the tribal nations level, we're helping them at all different levels throughout our country and other countries. And this is the way to move this forward. This is the way you build your community. This is the way you have scientists interacting and the new scientists that come up on board because of these community developments. And it brings in sociologists, it brings in folks that are going to be our future policymakers, our future statesmen. And this is how you build a global community. Finally, we must continue to promote the rapid distribution of our research to colleagues, stakeholders, policymakers, and the general public through extensive communication effort at the local level, at the community level, at the state level, and at the federal level, and also at the international level. It's the international meetings that we've had over the years that help build that connection between our various countries and build that connection between the data centers and allowed us to communicate the importance of ocean acidification and carbon cycling to the world. And through that interactions, particularly through the IPCC and other connections, our communities are well equipped to communicate that information at the national and international level. Last slide. So in conclusion, I think our challenges are very extensive and we need to increase the throughput and the measurements while providing at the same time high quality outputs and data products that we can all utilize. We as scientists have to work very closely with our policymakers to reach consensus on what these new services and data products will look like and how they can be made available to our entire community. And we need to work together with our chemical and biological scientists in order to make sure the new technologies that are coming online in the near future will meet the technical specifications of our global observing system. That's a great challenge for the scientists and particularly young scientists that have the ability to develop these new approaches and bring them online quickly and successfully. And with the new work with Marine CDR, I expect to see much of this being enhanced with the new kinds of observing capabilities that will bring to bear on this new research that's just coming on. And I'm hoping the ocean acidification community, the GOA-ON community, will provide a major contribution to marine CDR research by providing the background information, the approaches to the sciences that we have learned, and provide the guidance of how we will utilize that data within our databases as we have in the past, and bring that community into our ocean acidification community in a way that benefits all of mankind. Thank you.
Thank you, Dick Feely. That was a sensational presentation. Your perspectives are so spot on. We can't thank you enough. I know we're a touch over time, so we don't have time for the general audience to weigh in, but Katarina posted the kudos board, so make sure you're contributing to that so that Dick can hear from anyone who wants to. Katarina says we have a few minutes, so let's take them. I'm going to turn the floor over to Katarina to take us out. Dick, I want to just, on behalf of everyone, to thank you so much. And I'm wearing a calcifier. It is actually a sunrise shell from Kauai. And welcome to the sunrise of your retirement.
Thank you. Thank you.
Thank you, Dick.
Very appropriate. Very appropriate. Well, you have all touched my heart deeply, and I really appreciate this day. It meant a tremendous amount to me. And thank you for setting this up. Thank you for making this happen, Jan and others, and Katarina. And thank to all you, my very dearest friends.
Thank you, Dick. Over to you, Katarina.
Sorry, a bit emotional here. Thank you so much, Dick. And just speaking from the GOA-ON Secretariat, we just would like to thank you as well for all the support you've given us through the years and all of your advice and wisdom and enthusiasm. So thank you very much. I would just like to thank everybody for their contributions to this very special session. And I would like to thank the audience for being here with us and for following. This has been, the first very special session we've had in OA Week 2025. We are on the end of day 4 of this OA Week. We have a few more sessions coming up. And if you want to know more about what is happening, please follow the QR code down here to see the full program of the upcoming days. If you've missed any of the sessions, keep an eye out. We're going to be sharing all of the recordings on our YouTube channel. And if you're not a member yet, we encourage you to sign up to become a member so that you'll always be among the first to find out about events such as these today, and to keep abreast of everything that's happening in the world of ocean acidification. And with that, I thank you very much. Have a lovely rest of your day.